how is the configuration now done? This is now the logical view of that, what we have seen now from the engineering system. So this is now where it comes a little bit more to the case of how do I develop and what to do there. We have always in our configuration a bus interface. This is our entire device slot where, let's say here, if I go a little bit back, where your Ethernet connection is. This is the bus interface. So that means there is somewhere a device or an entity of the device, a hardware entity, which represents the communication function. It's always there. So if this is just a single block of hardware, or if this is a modular system which you can plug by yourself, doesn't matter. There is always such a bus interface required. This is the device access point tab, and this is something you will also find afterwards in your configuration file, such called generic station description, a GSD file that you need to configure for or need to set up for your device. And this is the common understanding what is implemented then by the engineering system. And then we add in modules our information. That means we have several modules. At least one is required. And in each module, we have submodules. Now we need to distinguish between two different views on the system. On the one hand, we want to have data. We want to have process information. That means, let's say I have here a digital input module where a biosensor is connected to, and this one has to transmit if there is, let's say, something in the range of the sensor, or there's nothing in the range of the sensor. That means you get a stupid 0 or 1 digit. This is the data that needs to be transported. And that's why the data is here ordered in this submodule. But there would be in advance the opportunity also to give additional diagnostic information. Diagnostic information, for instance, of a wire break or a short circuit. If this is, let's say, an output module, then there could be an overload of the channel, and the overload is nothing else than a short circuit in the normal cases. And then this is something that can be diagnosed. That means we need to distinguish here between data, real-time data, process data, however you will call them, and the alarming, the diagnostic information. And this is now something that we distinguish between, so let's say, an address information and a data information. So the data is organized in modules, submodules, while versus the addresses are organized in slots, subslots, and API. This is now a really theoretical view, but this is something you immediately see if you look into your development kit from a technology provider, and then you see the distinguishing, but that you have at least heard it once, yeah, that we distinguish between addressing information and the data information. Addressing information is required to get the diagnostics out of that system, and also they exist in the PLCs blocks to get data out of the address information and vice versa. So this is possible. So you can translate from one addressing system to the other one. That is possible, but here it is, let's say, to organize the data inside of the device, or let's say the process data, to be correct, the process data and the diagnostic information to distinguish here and to read the right information over the right way. What is this exactly, and how is it done in your development kit? Then please refer to that what you get from your technology supplier. There you get then more information, not just that you've heard this. If this is now sounding a little bit confusing, it is not in the end, because then you get an entire example in your development kit, and then you understand it very quickly, but only to give you a rough understanding that we really need to distinguish between them. And it makes sense also to distinguish.